So we're going to move on to technology, and joining me for this section is Steve. We're going to kind of take you through a bit of a good, we're that way around. A bit of a kind of lazy river ride of how we see engineering and technology proceeding in the near future, and trying to debunk some of our inbuilt reliance or perceived reliance these days on technology. So for those of you who don't know us, we thought we'd just do a little quick introduction of who we are, and I apologise. So, yeah, this is me. I'm not an engineer, not by trade. I was a theatre grad, unbelievably, so I changed professions pretty quickly. I think of myself more as a technologist. I've always loved technology, and technology to me is not just electronics and lights and sound, it's structures and buildings and flows. Part of the way I think my brain is wired is I remember, as some people know, quite a lot of trivia from years gone by that you can then help to pull things together. So somebody who I've met 2 years before doing something very weird, maybe something that we can help pull together. And that's part of the way that I've tried to structure these technology sessions that we're going to look at, which is stuff that people are doing, which is why I said stuff earlier. To try and pull it together, but pull it together in a way that's engineered. We're trying to stay away from the glowing screens, which I have a hate of. It isn't necessarily the be-all and end-all. An application is only as good as what you start with. Garbage in is still garbage out. If it's not engineered well, it won't perform well. But anyway, Steve?
I'm Steve, and we're glad to be here. I grew up in Orlando. When you grow up in Orlando, you work for Walt Disney World. I come from a family of engineers. My dad's an engineer. My oldest brother, Glenn's an engineer. My middle brother, Dan's an engineer. So lacking any other vision for my life, I became an engineer. Disney, I worked at Disney to pay for my school, and it was a great experience. So I've often thought, coming from this family and this background, that the engineers are underrepresented. In this forum, I've often thought that the T part was underrepresented, because if the engineers are doing their job right, you never hear from them. They're transparent, and you only need them when something's gone wrong. So that's just kind of the wiring, the DNA of an engineer, is that they are in the shadows, and that's, if they do the job well, that's where you see them. So.
And we're going to kind of wave the flag for them a little bit in this whole presentation. Yeah. We hope. So we thought we'd just run through it. We started off with there's no app for this, and you'll see why we moved through that. So engineering, it's a definition of what we do as an industry. It's the branch of science and technology concerned with design and building of engines, machines, and structures. Something that the art of working artfully to bring something about. An app is a self-contained program or a piece of software designed to be downloaded to a phone or something. Again, that's a piece of a tool in our box. It's not the be-all and end-all, and it's not the whole reason for being there. Application is exactly what we do. It's the action of putting something into operation. That's our business, is engineering something that comes through to a final operation. So, part of my hatred of us is, certain parts of applications, is our complete and inane belief that the app is going to work. That it's always going to be there, it's always going to be fine. Oh, until we get that one. And just for some others in the audience, we also have that one. But what do? We turn it off, we reboot it, we go, hey, that's fine. That's us at home. SATNav is the be-all and end-all. I couldn't get the picture because I couldn't find it. I moved from one country to another and had the directions for the driver to stop at the end of my lane, which is a mile long. Because there's a 90-degree bend, you can't get a 40-foot truck round with a container on it. He ignored those instructions and followed his sat-nav, even though you could painfully see that the truck wouldn't go around the corner. So tow trucks, 24 hours later, I finally got my furniture up to the house. But people do that. The blind reliance has led to a lot of cut and paste. If 4 inverts and 2 twists works for them, well, 5 and 1 more must be better for us. The engineering principles behind it are kind of sound because we can do it, but it doesn't necessarily give us the best experience. We're quite lightly regulated in our industry, and this is one of the side tracks, because we engineer very well. We care about what we do across the industry, from initial creation through to final production and operation. If we weren't, we'd have to do a lot more stuff like this before we could bring anything to market. We don't do, and we're not, the regulatory authorities don't bring us into the realm of having to do destructive testing before we can bring anything to market or have anything involved in people. We do a lot of engineering, and some people say we over-engineer, but we engineer to be completely safe. Sorry. There we go.
This is a great picture. I love this picture. This is at the beginnings of our industry. The Crystal Be Cyclone, this legendary coaster. You have to imagine there wasn't a lot in the way of CAD drawings or stress testing, or the builder had to be as adventurous as the first rider. You go ahead and be the first rider. No, you go ahead and be the first rider. There probably wasn't a lot of application of standards and testing, that sort of business. So it says it was built in 1927. It was the only coaster to have a nurse on duty at the loading platform full-time and with good reason. As riders plunged down the first 97-foot drop, the track veered 85 degrees to the right. Passengers lost hats, purses, combs, and false teeth. They were thrown into their riding partners, cracking ribs. Many fainted. By the end of the 20 years of operation, many more people were watching than riding the Crystal Be Cyclone. So that's the beginnings of our industry. It's always amazed me that, on the projects that I've been a part of, oftentimes there'll be a rendering at the beginning of the project, and whoever created the rendering will say, "Here's my design. The design is complete." And it's like all you have to do now is build it. And it's just the very tiny tip of the iceberg. This is where the work starts. It's always mystified me that some of the terminology maybe needs to be changed around on this.
Some of it doesn't help. I mean, there's Minecraft, which is a great game. You just built your own theme park there with a 3D printer. I guess now you can hit print and you've built yourself a theme park. It might defy every law of physics and anything to do with structural dynamics, but you could do it, I guess.
This is a real zoomed out view of just one step in the process, a methodology for creating a safety strategy for a new attraction. You have to identify and assess the risks, and then have a plan to reduce the risks. And so this process happens early, and it is an iterative process until you've nailed them all down. So this is the very beginnings of the process.
We're getting better, obviously. We've learned from other industries, and we rely on a lot of other industries to give us our data that we need. The car industry produces a lot of data to do with G-force, crash, and stress testing. We borrow stuff from them, crash test dummies, and we put them in rides. And we record a lot more data now. Again, most of it is either self-regulated or regulated by some outside authorities.
So consider a steel roller coaster, a modern steel roller coaster. What do you have? You have a launch system. You have maybe track switches, maybe have brakes, maybe there's other elements, many things moving, many moving parts. So back to that risk strategy, you need to test it down to the ground. One of the processes before you can commission a ride like this is you've got to break everything, you've got to fail, use fail as a verb, you have to fail everything so you know what will happen, what state will it will go into as a result of this failure. So this is a little clip. You'll hear my brother Dan's voice on this as he's testing the launch system on a linear induction motor rush.
Following approx 32. The train will abort when it gets there. Brakes will close, and we'll see how high it goes.
So you can imagine how many steps it takes just to commission a modern ride. So that happens, it takes days. The acceptance test procedures are thick. It takes days and days to go through these. So I love this quote. This is from the Wall Street Journal. Because of the design practice and the application of standards and the testing that goes into this, judging by data, roller coasters are remarkably safe, certainly safer than driving to the park. And that's very much the case.
So, not everybody follows the same strict. You're going to guess what's going on here, really. The same strict procedures. We've all seen these, I guess. I don't know how many of you would love to do this. I've done something vaguely similar a long time ago. This one is a great one if you want to find it on YouTube. It's the lawn chair roller coaster. But I don't know how many people have seen it. There are actually now theme parks where you can ride the machines. I've been there, I've done it, it's great. It's re-engineered and retested. But basically that's a carousel made of backhoes. And they have sky swings made of lulls and all that kind of stuff. It's great.
So here we introduce this notion of stepping into the machine. A lot of theme parks technology is lifted from other industry. In the case of control systems, a lot of it is lifted from industrial control systems because it's a very robust system. It's a lot of years on the control systems that are used in industrial systems. So here we see a Kuka robot. The operator is behind a cage. He's out of the machine. The Kuka robot is providing some assembly process. And this is very wise. It's a very safe system. It's prudent. Keep the guy out of the machine. So that's an example of an industrial systems. You might imagine there might be a sign there that says, be careful, this machine has no brain, use your own. Now, the oldest joke in the book in the theme park world is, well, heck, the guest leaves their brain at home and you have to think for them. So in our world, everything is flipped upside down. In theme park world, the same Kuka robot, the guest is invited on the machine. The guest is in the machine. So all the design practices is flipped on its ear. So this is a great quote from an engineer friend of mine. He sums it up very well. Industrial control applications are almost all in the manufacturing world where safeties are anchored in shutting down the process whenever a human gets close, while theme park control system engineers are working on human-rated machines where the hapless vertebrate is paying money to climb into the machine. So it's very well stated, and it just speaks to our industry and how different the rules are. So, why is this important? Because we're not building rides and shows. We're building lawyer opportunity zones. So this goes back to the comment about the acceptance test procedure, and over the years we have seen them get more and more rigorous because the design practice in the commissioning and so forth has to not only be defendable to the people close to the project, the engineers and so forth who are close to the project, but it has to be defendable to people who know nothing about it in the legal environment, people that are, have no understanding. So that increases the need for the design rigor and the defendable application of standards and the commissioning and so forth. So we're not building rides and shows, we're building lawyer opportunity zones. Now, just to bring this point home, I've given similar talks to grade school students about engineering and how they might be used in theme parks, and everybody gets it, but the kids get this instantly. This is from a fourth grader. My brother Glenn received this after we gave a talk. And it says, Mr. Birket, thank you for the presentation. I thought the presentation was wonderful, especially at the end. I do not want to be an engineer, but I want to be a lawyer in case your safety things fail. Thank you and see you in court. That's a fourth grader. Fourth grader. You can't make it up. I didn't make it up. That's true. So we talked a minute about ride systems and how when a person gets into a ride vehicle, it's someone stepping into the machine. So all the very same things can apply to show systems. Now, this is possibly the best stunt show in the world. Thank you, Universal Studios. This is Waterworld. Now, in this case, there's not a person stepping in the ride vehicle, but there's a stunt actor stepping into the machine. Now, he's on stage, and let's think about all the elements that are at work here. There are show doors, there's gas flame effects, there's pyrotechnic effects, there's overhead rigging effects, there's bullet hits, there's water cannons, there's show action equipment, there's a water ski, jet ski launcher, there's a seaplane launcher. All these things are happening, and all of these people are in the machine. So how do you keep them safe? So the same principles apply. The design discipline, the application of the standards, and the testing So how is this realized? So there's several things that work. There's a show controller that will be stepping through all the events for the show, like it would in a theater performance. But then that controller is looking at subsystems that have their own system that are only looking at a given subsystem. So, for example, there will be a processor that's only looking at the gas flame effect, and there's another one perhaps that's only looking at the pyrotechnic effects, and another one that's looking at the show doors, and another one that's looking at the jet ski launcher. And those subsystems, what are they doing? They're looking at maybe hydraulic pressure. They're looking at endpoint detections. They're looking at the intrusion fence to make sure that the stunt actor is out of a certain area to keep him safe, and that he is in a certain area on his mark. Maybe we're looking at the wind for the pyrotechnic effects. All of these things are managed independently by subsystem controllers, which are clocked through by the show controller. And on top of that, there's a technical director who is standing with sightline to all the events. So even if the system tells him that a given effect is safe to proceed, he can disallow it if he sees something that he determines, well, we're going to skip that effect. So there are layers of safety in a modern show.
It's not just controls. We had 20 minutes, and when Steve and I first talked about this, we could have done a week-long SATE conference, and there are other people that do conferences on certain parts. It's a team thing. The engineering starts at the very beginning, runs through to the end, and the best produced shows are engineered from the beginning. Design engineering is just as important a part as initial concept design, because if you get the right set of design engineers working with you, you will produce a concept that's out of this world, because stuff that you thought was impossible may be absolutely possible, or they may have a good twist on something that you really want to do, but you can't work out how to because of some gravity-defying reason. But they're all part of the process going through. One of the... we asked around for a few quotes, and most of them said, it's the can you just in that last week before you're going to open when everybody's screaming and shouting. Can you just move it a little bit to the left? Can you just add a water effect? Yeah, it's only 1,000 volts, it doesn't really matter. Can you adjust that by half a second? Of course, this half a second here has a throughput capacity change of 400 visitors an hour. Did you realise that? And some of the best ones is like the lighting designer make it look ominous, and the programmer says, well, what's that in hexadecimal? These phrases take it all the way through. Engineers are everybody's friend. They need looking after every now and again and treating nicely. Just bring them out, buy them a beer, put them back in the dark. But it is about precision and about trying not to cookie cutter the industry into becoming the themed entertainment app. We are brilliant at what we do. The whole room full of people, everybody, the companies that we all work with. But we have to be careful that we don't end up in that 5-inch screen, 7-inch screen, 10-inch screen, 90-inch screen, 120-inch screen. It's about the whole environment and the process from start to finish. And I think that's probably it. Thank you.